That's great. GDPR, everybody's favorite topic. And we go back to a slightly more geeky world with PhenoPackets and Jules.
How do I do this? Is that working? Yeah, cool. Good morning. I'm going to be talking about the PhenoPackets project and its role in the clinical phenotypic data capture. So the, how does this thing look? Sorry. So that what we're trying to do is to capture patient phenotypes and to enable these patient phenotypes to be used in a, in a computational manner so that we can actually solve the, come to a diagnosis from these things. So this is the current state of the art of patient phenotyping at the moment. Really, it's just sort of some handwritten notes that the doctors have come up with. There's a lot of information in there, but the computability of this sort of thing is quite far away. So we need to try and make sense of all this data so we can actually use it for some proper computation. So we need to encode this data. So we've already got things like genetic computation, computable components such as base pairs, and then moving up the sort of food chain into things like HGVS and other things. For phenotypes, we've got the HPO for the human phenotype ontology. There's a mammalian one for other non-human mammals. But these on their own don't really have enough sort of structure, so we need to say, well, how do we get this phenotypic information from about an individual to some other person so they can actually use this information? So we have standards already for things like for the genomes, the very successful standards, like the wonderful VCF standard, but we don't have the same kind of thing for phenotypes at all, and we need to really redress this so we can actually start to exchange phenotypic information between centres. So there are lots of different ways of encoding this kind of information, and we've got a very basic, easy one to use as a list, which are sort of actually is our current state of the art at the moment. And then we've got CSVs, which are a little bit better, but these things aren't really totally suitable for transmission and easy ingest, because they require a bit more knowledge about what's actually inside it. Right to the other end of the spectrum, we've got things like the FIRE standard, which is the current sort of clinical incumbent, and then things like RDF, which are very generalized and expressive, but they can be quite hard to work with. So we want to try and aim for something which is just in the middle of this gap, where people can actually put their phenotypes and come up with something which is easy to use, easy to share, comprehensible, easily comprehended. And yeah, so that's the goal of the PhenoPacket. So why would you want to do this other than just a list? I mean, let's just take an example, walk you through it to show you what a PhenoPacket looks like, a brief example. So a single term on its own, craniosynostosis, this is the description of this phenotype that you can see here. So that doesn't really give you a lot of context in here. We can get up to the list of terms, and again, it doesn't really tell you a lot. So, you know, we can do better than this. We need to say, how do these set of phenotypes link to, say, the patient? How do they link to their family? Were these phenotypes actually not observed? So some of these could be observations to say that this patient definitely did not have craniosynostosis, however they did have the brachydactyly. You also want to know when were these phenotypes first observed, and severity and whatever else we might need. So we need some structure. So this is a little explanation of sort of a basic structure of a PhenoPacket. So we've got the idea of a patient here with an identifier, the sex. Again, all of these things are all computed by using ontologies. So we're using the Pato ontology here to say that this is a male. And then we've got the human phenotype ontology being used here to describe the proptosis that's going on in this patient. And so they've got a severe case of proptosis, and it's a congenital onset. So that's the kind of the serialized format of this thing, but it's actually a schema that we've got. So there's a schema definition in the repository. If you'd like to have a look at that, then that'd be really awesome. But then moving on from that, we say, well, can we actually use this thing to bridge the gap between EHR systems, such as a FIRE system, and moving it out to some computational analysis, such as the Exomiser? So that was our goal. So we had a couple of demo applications we built to sort of show the utility of this thing. And the first up was the Monarch Web Exomiser. And this one, we just take basically the clinical notes that you've just seen, but in actual entered text rather than some OCR. And then we annotated these things using, this is developed by Judah Groser's team in the Garvin, or X team. And we've annotated these, I don't know if you can see here, we've got so this is the input text here, and then the blue underlined here are the terms that have been recognized by the software, and then these have been turned into these terms here for the extracted phenotypes. Here you can then actually download the PhenoPacket for this particular case. For your sharing later, or in this case, because we want to do something useful with it, we're going to put it into the Exomiser here. So we're saying that what GML assembly it's been called against, and uploading the VCF file along with the phenotypes. So this is using the PhenoPacket at the back end to actually move the data from the front end that you're seeing at the moment to the Exomiser server, where it's going to analyze the VCF file. This are the results that come back. So the case notes were for someone suffering from a mild case of Pfeiffer syndrome, and we've got here a rank list of genes where we can see that FGFR2 gene is a well-known causative gene for this particular syndrome. So it's got a good phenotype score here, we can see there, and a pathogenic variant has been found in that position. So that was a kind of a more simple non-clinical use case, but the clinical case, we have a Smart on Fire application. So we built a demo application sitting inside the CSIRO Smart on Fire setup. So the application here, we've got a clinician is interacting with a Smart on Fire application here. And the Smart on Fire application is reading the data from the Fire server. Because the Exomiser requires HPO annotations and the terminologies being used within the Fire server here are actually in SNOMED, we're using a terminology service to translate between the SNOMED and the HPO terms. So this is then sending back a Fire bundle to the Fire to PhenoPacket service, which is, again, on the GitHub repo that I mentioned earlier. I must say this is just very basic kind of proof of concept. It's not fully battle tested. And then this is sending back a PhenoPacket to the front end, which then tells the Exomiser service where it can find the VCF file that it needs. So this would be a really, really good case for HTS-GET. I'm quite excited to include that in here. And then the Exomiser is performing the analysis on the VCF file and using the phenotypes that have been included to come up with this analysis. And then these get sent back to the service where the clinician can then make some decisions. So I'm just going to walk you through the screenshots for this because this is going to be a demo, but we weren't allowed to do a live demo. So we're getting the authorization here. We're logging in. This is the EHR system that the clinician will be looking at, and they can look at either their applications they had available to them or look at their the patients they have available. So they can see here, this is the Exomiser Analysis Smart on Fire app that we built. And these are the patients that the clinician has available to them. Seeing as we're not working on real clinical data, we have to have a couple of demo patients here. So we're looking at Miss Demo Girl. We've got a very, very basic patient information page for these things. And then here you can say there's the Exomiser Analysis button. So we're going to push this button here. And we move on to the original case notes that we used in the previous example as well. And here we've had a clinical geneticist or the clinician has actually marked up the case with some coding concepts within the Smart on Fire application. And these ones are the terms that have been translated from the SNOMED to the HPO. So again, we've got some similar terms here. These get sent off to the Exomiser service, and we come back with the set of results. Again, we've got the FGFR2 as a result from this. And because the phenotypes were slightly different that we input, we got slightly different results coming back, but we still got FGFR2 as a strong candidate. And if you look at expand the panel here, we can see why the Exomiser chose this particular, this model over the human model here, because it was a slightly better mouse hit based on the phenotype it matches. And here, again, we've got the causative variant that's been highlighted for why they're coming up with this. So that's just the example of how all of the PhenoPacket and how it can actually be used in a system where we're interfacing with a clinical system or even with non-clinical systems. So I won't read all this, but this is just a sort of few use cases where people could be using it. We've already got, I'll say it, maybe I will. We've already got exported biosamples from, exported PhenoPackets from the biosamples database at the EBI, which is really awesome to see. And then also the EGA, because obviously it's the European Genome Phenome Archive, apparently don't have a model for phenotype ingestion or export, so they're also considering using the PhenoPacket as a standard for this. Again, the IMPC, this is the International Mouse Phenotyping Consortium, have expressed interest in using the PhenoPacket as a way of transporting their mouse phenotypes around the place. So I'd like to say that the PhenoPacket doesn't have any requirement for any particular ontological system to be used. You can equally use it with SNOMED, or you can use it with HPO or any other coding system, but the requirement within the spec itself is that you have to say what these coding systems are and where they come from, so you can actually compute against it using, say, some kind of reasoner or something. And we also have journal articles, journals interested in having these into their journal, included as a journal article submission. So the phenotypes, we don't have to go through the text-based parsing bit. We can actually have researchers or clinicians input their findings in terms of an actual structured PhenoPacket directly with their manuscript, so that these things are much more computable right from the outset, rather than having to go through the curation step. So this is just pretty much kind of what I've just said. The potential use cases for how all these things work out. The plans for the future, well, I kind of want to expand on the usage of these things. I think I've already said all this already. So, yeah, acknowledgements. So this is the work stream, people who've been working on this. And, yeah, I look forward to your questions later. Thank you.